Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So let's write some chemical equations from names to formulas. And first, if we were to look at copper and have copper by itself, that's just Cu. In the solid state, we would put a parentheses and an S next to it. And we're going to react that with solid sulfur. S is sulfur. And we're going to form copper 2 sulfide. Now, copper 2 means that the charge of the copper is +2. The charge of the sulfide is -2. So 2 minus 2 is 0. We don't need any more coppers or sulfides in the formula of copper 2 sulfide. Cu2S then is its formula. And it is a solid, so we'll put an S next to that. And you can see this is balanced. There's one copper on both sides of the equation. There is one sulfur on both sides of the equation. Now, when we take solid iron 3 oxide, okay, iron, the Roman numeral 3 in the word means the charge is +3. Oxide is -2. So to get these to balance out, we're going to have to find the least common multiple. Least common multiple between 2 and 3 is 6. So to get 6, I need 2 plus 3s, and I need 3 minus 2s. So here I would have +6, I have -6. That's going to be neutral. So my formula is really Fe2, because I have 2 irons, O3, because I have 3 oxygens. And I need each of those to balance the charges out to get no charge. Now that iron 3 oxide reacts with hydrogen gas. Hydrogen gas is H2, not H. There are 7 elements that form diatomic elements here. Hydrogen is one of them. And that's going to form solid iron. Iron is just Fe. Solid is S. And liquid water. So water we know is H2O and an L. But this one we're going to have to balance. And so to try to balance this one out, let's take a look at what we've got. We have 3 oxygens, and we have 1 oxygen over here. So if I put a 3 in front of the water, that'll give us 3 oxygens. That balances out oxygen. We now have 3 times 2, or 6 hydrogens on the right. We need 6 on the left, so we're going to need a 3. 3 times 2 is 6. Now the hydrogens are balanced. Iron, there's 2 on the left. There's only 1 on the right. So if I put a 2 in front of iron, we balance out the iron. In the next one, we have sulfur dioxide. Di is 2. So dioxide means it's a molecular compound. It's only nonmetals. We don't have to worry about charge. Di tells us how many there are, 2 oxygens. That is a gas, so we'll put a G. Reacts with oxygen gas. Oxygen gas is also a diatomic element. It's always found in 2s. That's going to form sulfur trioxide. So tri means 3. And now we just have to go and balance the equation. And so you can see that we have a difference in the number of oxygens. We've got 4 on the left, and we've got 3 on the right. So in order to balance out our oxygens here, we're going to have to also do some changes to our sulfur. If we make this SO2 a 2, that's going to get us 2 sulfurs on the left. We'd also have 2 sulfurs on the right, but let's take a look at our oxygens. 2 times 3 is 6 oxygens on the right, and now on the left, we have 2 times 2, which is 4 oxygens, plus another 2 oxygens. We have 6 oxygens also on the left. So that balances out this particular reaction. And finally, if we take gaseous ammonia, which is NH3, and we react that with gaseous oxygen, which we know is O2, we're going to form gaseous nitrogen monoxide. So mono means 1, so NO. And we're going to form gaseous water, so H2O, G for gas. And now we can go and balance our equation here to make sure that we have the same number of each element on both sides of the equation. And this one's going to be a little tougher to balance, so watch what happens here. So for instance, we can see we have 3 hydrogens on the left, 2 on the right. So the least common multiple here is 6. So to get 6 on both sides, we would have to put a 2 in front of the NH3. That would get us 2 times 3 or 6 hydrogens. And if I put a 3 in front of the water, 3 times 2 is 6. That would give us 6 on both sides. Now, if you also notice here, that gives us 2 nitrogens on the left. So we would have to put 2 here on the right. Now to balance out the O, this becomes the tricky part, because if you notice, I have 2 O's from NO. I have 3 O's from water. So that's 5 O's. That's an odd number. And I can only get an even number from our oxygen. Now to make any odd number even, we can multiply by 2. So the way that we have to balance this equation is the coefficients we've already added. We're going to multiply those by 2. So I'm going to take out the 2, and I'm going to take out the 2 and the 3. I'm going to multiply them each by 2. So that 2 is now a 4. That 2 is now a 4. And that 3 is now a 6. Now what does that do for us? We have 4 oxygens from the NO. We have 6 oxygens from the water. That gives us a total of 10 oxygens. That's even. So now, if I put a 5 in front of the oxygen, 5 times 2 is 10. And now I've balanced all of the elements in this equation.